So this video we give you more in detail about the concept of kinematics and more specifically the particle kinematics. So let's go to the particle kinematics. And in the particle kinematics, there are two types of motion that we are talking about. Two types of motion. What are they? It rectilinear motion and curvilinear motion. So let's talk about the first one, the first type of motion, which is rectilinear motion. So in that one, basically the objects move on the straight path, right? For example, let me here on the straight path. For example, from point A to point B. So in here, we want to know the concept of position, displacement, velocity, and acceleration. So that somewhat you study that in physics, just make a quick review of those relationships. So we have position. Position can be determined by radius or more with you see the vector, position vector. Something that we learned in earlier in statics, 3D forces. We also talk about position vector, or we can also talking about displacement as. Okay, so I can make a note here that basically a vector, and that one we talking about the coordinate. And of course, the next concept we were talking about is velocity. Velocity. So that will be V, and you already know. And then the next concept in motion will be the acceleration. And that will be A. And if you recall what you learned in physics, to find out the relationship between velocity and position, or if we know position, how can we find out velocity? We can take the first derivative with regard to time. So if we have position, we want to find out velocity, so we can take the first derivative. So d position vector over dt. And if we know the velocity and we want to find out acceleration, then we take another derivative with regard to time. So it will be A equal to the velocity with regard to time. And in the case that we know the acceleration, so just backward, you can, instead of derivative, then we will take the integral. So to find out velocity, similarly, we have integral of acceleration with regard to time. And then similarly, if we know velocity, want to take a position, then we take another derivative of the velocity with regard to time. And as you can see, when you take the integral, you may have the instant, you may have constants. So in that case, how we determine the constant? So I'll make a note here constant will be determined from initial condition. Initial So what I mean by initial condition, for example, if you have a particle at rest, so initial condition will be at time 0, you have the velocity 0, right, at rest. So that what is initial condition. So for the rectilinear motion, we have position vector or s, coordinate or velocity, we have v, acceleration a, and each component we can find out the relationship from position to velocity, take derivative. Similarly, if velocity go to acceleration, we can take the another derivative. And if you have acceleration, we can take integral to get velocity, take another integral to get position. So something that you already learned in physics. So that practically rectilinear motion. So let me move on to the other type of motion in practical kinematics, which is curvilinear motion. So curve, it means they move on a curved path, right? Curvilinear motion. So let's give that in a 2D for now. You have y, you have x, and in a path that they move, it can be a curve like that, right? So it can be any random curve, as you can see. And at a given point, for example, at that point, the particle there, then a certain displacement that you can have, which is ds, coordination, right? Then at that instance, we have the velocity is tangent to the path, and that we have it v, right? Velocity. And at the same time, we also have acceleration. For example, let me move out to the other point here. They moved out to here. When we want to find out the acceleration, then you also have two components. Okay, and what are the two components in that point? We are going to show you a little bit later. But now let's talk about velocity. So that you can see from the relationship between the velocity and position. To find out velocity, we want to take the first derivative of position. So what does that mean? I have velocity v equal to ds over dt. Now if a vector, then we have a vector here. ds over dt is scalar. So if you recall in 3D forces, the force vector equal to magnitude times a unit vector. So we can do the same here. Let's call the unit vector tangent to the path is u t. T stands for tangential. Unit vector u. So if we call unit vector is the vector with the magnitude equal 1. Right? So that what you have here. So let me go to define what is that. So that basically scalar. And that one is unit vector tangent to path. To the path of motion. Okay, so if we can draw that unit vector, it will be there, right? At that instant, that ut there. And it's dimensionless. It's dimensionless. So whatever the unit ds over dt will be the unit for velocity. So to simplify it, you can see ds dt, that is the speed. So speed, from that I can rewrite this equation at v equal to v, speed or magnitude of the velocity, and then time the unit vector ut. So multiply relationship between the velocity and the displacement or coordinate, and we can represent the vector, the direction of the velocity with the ut. So one characteristic of the velocity, as you can see in, I draw in there basically a velocity, and make a note here, velocity in the curvilinear motion, it will be is tangent to path of motion. Okay, so that one note, very important, that we need to keep in mind. Tangent to path. So that is velocity of a curvilinear motion. How about acceleration? As I speak earlier. So in acceleration, let's draw that out. What is acceleration here? We, to find out acceleration, as you can see there, we can take another derivative of the velocity. So let's do that.